Okay, so we're basically just gonna go through a few slides, kind of like split it into sections. So like show a few slides, and then show like the physical rocket, and then do a few more slides, and then show the rocket. Basically, at any point, if you have any questions or anything, feel free to stop us. Otherwise, we'll just keep going.
Yeah, just go ahead and finish your presentation, and then we'll work our way back through as we ask questions.
Okay, we can finish it then.
Okay.
So, let's see here, just starting with the airframe. All of our airframe, our couplers, everything is made of G10 fiberglass. Our outer airframe diameter is 6.625 inches. Our coupler diameters are 6.5 inches. The overall length of our rocket is 144 inches. And then the white is just a wrap. It's like a heat shrinking wrap. So we're gonna add the stickers for the sponsors and stuff later, but for the most part, that's all done. So then moving on to the boat tail. I was just gonna start, by the way, kind of from the bottom of the rocket and go up. So for the boat tail, it's student designed, it's 3D printed out of PETG. It has an LV hack shape. And then as you'll see later, the inside has like 2 layers of a fiberglass like wet and stick. And then also 1 layer of this like aluminum rubber tape. It's like reflective. All of this is going to act as an insulator from the heat from our motor. The motor itself is an Aerotech M1939. As of what I did today, we have an apogee of 10,500 feet roughly. So the weights I took today, the measurements are all accurate. The motor is in hand, we have it, so we don't have to worry about it getting shipped or anything. The fins, so our core of the fins is made out of G10 fiberglass also. It's an 1/8 inch thick. You can see in this picture, it's tab slotted. So these are our centering rings. This is a motor tube. This is our boat tail. So this is our fins without the outer airframe. And then we have a tip-to-tip layup with 4 layers of carbon fiber down here. And then I just had a quick like time lapse of us doing one of the tip-to-tip layups. Yeah, so then we just finished it by cutting it with like a Dremel. We sanded it down and then used like a shiny paint over top. Okay, so then for the recovery, starting with the drogue chute, it's a 60-inch chute made out of a flame-proof Kevlar. All of our parachutes are made by Rocketman Parachutes, and most of our hardware is also made by them. We have a 10-yard, 1-inch wide nylon shock cord made by Fruity Chutes connecting that. We have a prediction that this drogue chute will slow the rocket to 50.5 feet per second. And while this is flame proof, we're going to be placing it in a Nomex blanket just in case. And then I have all of our hardware listed out. So stainless steel swivels, quick links. We have forged steel eye bolts, and then some Kevlar soft links. So depending on where it's placed, we either use the stainless steel or the Kevlar. And then for the electronics, Adam, if you want to talk about that a little bit.
I'm Adam Stevens. I'm the electronics lead. So for our primary altimeter, we're using the Featherweight Raven 4. And for our backup altimeter, we're using the Ultras Metron and Telemetron version 3. And so that will also act as our GPS recovery system, so we can locate the rocket. The sled was 3D printed using PLA, and we're using 2 mechanical screw switches that will be used to arm the rocket.
Yeah, so we'll show you that later, but it has like these 2 aluminum bulkheads on the ends. Then for the deployment testing, I had a couple of videos of that too. I'll try to turn down the volume, but it like won't let me.
You guys ready?
Mm-hmm. Yeah.
I'm sorry if it's
Okay. And 3, 2, 1, pop.
Whoa.
That was enough charge.
and that's our flyer of record, by the way. He was helping us with the test.
You guys ready?
Mm-hmm. Yeah.
You ready?
Yeah.
Yep.
We are going in 3, 2, 1.
Okay. So for our main parachute, we've got a 144-inch high performance nylon ripstop chute. Kind of looks like this. It's like orange. And we are using the same kind of shot cords, but instead of it being 10 yards, it's 14 yards. It's going to deploy 1,000 feet from the ground, and we predict that it's going to slow the rocket to 13 feet per second. This parachute is going to be placed in a deployment bag, which looks pretty much the same as this one. And all of the hardware is basically the same. So then moving on to the nose cone and the payload. Our nose cone is student researched and designed. It's 3D printed with a carbon fiber like infused PLA, which is also an LV hack shape. Our payload, which is a little bit different from this, but it looks very similar. We've made a few tweaks. Is this like round aluminum container. It's going to sit in the nose cone, so that like the rest of the payload is going to be inside of this container. Yeah, so that's all we have for the presentation. So I don't know if you guys have any questions or anything before we show you the rocket.
Yeah. You knew I'd do that, right? Can we go back to the slide about the nose cone?
Yeah, just a minute. Can you see this?
Yeah,
Okay.
yeah. I guess can somebody comment on the carbon fiber PLA? And whether you believe it will hold up to the 100+ degree paint, 100 plus temperatures in New Mexico?
So I believe somebody did FEA on it,
Okay,
if it could withstand the temperatures and also like the load, like from the acceleration. So and the infill of this nose cone is like 100%. I don't remember exactly how wide the filament diameter is, but I think it's like 2 point something millimeters maybe.
okay. Have you flown another rocket with this style of with this particular material?
I'm not sure. The one from 2019 might have, but I'm not positive on that. I wasn't here in 2019, so I'm not sure.
Okay, all right. Let's back up to the slide that had your altimeters, or electronics bay, I guess, basically. Okay. So you're not showing us the charge wells or the hard point for recovery and stuff, right?
Yeah, so instead of charge wells, we're using like we call it a charge burrito. So it's like a piece of duct tape, like a pocket, and you pour the black powder in the pocket and close it, and then place it into the rocket that way. That is a recommendation that we got from our flyer of record. We originally did have charge wells, but he told us that the charge burrito would be much better.
Mm, I'm not sure much better is correct. I've done it the way he describes, and it'll definitely work. Had, okay, how many of those are you gonna have 2 of those? We'll have 1 for each altimeter, correct?
Yeah, like 1 primary and then 1 backup.
Okay. What's the sizes of your charges? Do you know offhand?
In grams.
How many grams?
I think it was, what is that?
So our top body tube, we currently have it as 6 grams. When we did testing, we're still gonna do another ground testing because it was a little too much for our primary one. So we're going to save the size. So our top body tube was 6 grams and the lower body tube was 7 grams since it's a bit longer and bigger. So we're gonna retest with a lower amount of black powder. So yeah.
So are you just gonna guess at the lower amount, or are you gonna retest?
No, we're definitely gonna do another ground test to make sure that it will work.
Okay, perfect. Okay, again, I don't have a problem with that. I just wanted to make sure that I understood what you were using for quote charge wells. And the tape method definitely does work. Like I say, both Elaine and I have used it in our level 3 rockets, so that's great. Okay, can you go back to your the list of slides for a second?
Yeah.
Yeah, so I can see while I'm thinking. Oh yeah, I know what I would do. Stop at your tail cone.
Mhm.
Yep. Okay. Okay, again, has this been tested with another rocket, or is this the first time?
No, this one hasn't. But after talking to our flyer of record, he told us that it was okay if it was considered like frangible in flight. So it's definitely designed to last for like most of the boosts, but it will likely be like destroyed at some point.
So how is your motor retained?
So most of it is we've got, it's not listed on here, it's called a thrust plate. And there's like a threaded rod that goes through like the end of the motor casing, and the threaded rod goes through a like a 1/2 inch thick aluminum plate, and our rocket, like our motor casing, threads onto that, and that plate is going to hold the motor casing in place.
All right, when you read the video to show the rocket, let's take a good look at that. Do you have the rocket there?
Yeah.
Yeah.
Okay, when we could do that.
Do you by chance happen to have an open rocket or a RockSim design of this that we could see?
Yes. I don't think the threaded rod is in the open rocket, but I could be wrong. But the thrust plate that I'm talking about is.
Yeah.
I'm opening up. I don't know if you can see it. I'm opening up the open rocket right now.
Yeah, it'll take a little, it'll crank for a couple seconds. No big deal. So you're using a forward closure with a threaded rod that's linked into a bulk plate, correct?
Yeah.
For motor retention?
Uh-huh.
Okay.
So let me.
All right.
So it's basically, it's this right here. And the threaded rod, you can't, it's not in there, but this is the plate that I'm talking about.
Mm-hmm.
This is the motor, and there's a threaded rod like right here.
Okay. All right. Okay. Go back to your slides for a sec.
Yeah.
I've got to think about this here and the recommendation that it can fall apart. You know, the so your fire record or mentor is saying that as long as it lasts through thrusting, you don't care. That it can,
Yeah, he said it's okay to consider it frangible in flight.
and what does he base that decision on?
I don't know. I'm not sure. Our flyer of record is Rob Dickinson. So he's with Ezra. But I don't know. Like he said it was okay as long as it lasted through like most of the flight.
So do you consider it disposable, a disposable part, and you would make a new one for any subsequent flight?
Yeah. Like if
Ideally, it was lost, but
And if you had to refly at spaceport, do you have a second one?
no, I mean we could print another one.
No, you don't get second flights at spaceport anyway.
Yeah, I
But
mean,
still.
yeah.
What, yeah, and the reason I'm kind of mumbling is it's the first time I've run across this. When you go to spaceport, make sure that the flight reviewers that review your flight there understand that this is a disposable item.
Mm-hmm.
And then when you check in, and you give your altitude and they review your rocket for damage and that sort of stuff, make sure they understand that that's a disposable item and you don't get penalized because it came off or whatever.
Okay,
Okay.
that makes sense. Yeah.
Now, what I don't know is what effect that's going to have on the flight. What would happen if you went through flight safety in New Mexico and they said, the flight reviewers there say, we don't like that design. We don't like the fact that it's disposable. Take it off.
Mm-hmm.
Could you still fly?
Yeah, we could still fly. Really, the main purpose of it was to increase our apogee by reducing the drag. Like structurally, it doesn't really have any purpose. It's really just there to reduce the drag.
Yeah, no, I understand. What the wrinkle you're throwing into this is, number one, it's 3D printed. Most of these are either made out of fiberglass or aluminum.
Mm-hmm.
So the fact that you're 3D printed with PTAG, even though you've got some layers of fiberglass and you've got some insulation tape there, yeah, you know, I just hope it doesn't, anyway. Because that motor hits pretty hard. That M1439 is a hard hitting motor, so.
Right.
But anyway, so just, I'm giving you a hint to be prepared to answer all the questions you can possibly about that.
Mhm.
Make sure that in your mind, it's a disposable item and
Mhm.
should be marked accordingly
Okay.
and not penalized for it falling apart
Right. That makes
after the
sense.
flight,
Mm-hmm.
okay?
Yeah.
Let's go back to, I think, let's go up on a couple of slides. I think that pretty well covers. Yeah, we'll get to it when we look at the rocket. Yeah. Okay, so Lee or Elaine, based on the slides, do you have any other questions right now?
Not based on slides.
No.
Okay. Okay, it's rocket view time.
All right. So Adam is going to share his phone. Actually, let me mute myself.
Oh,
I can, there we go.
Okay,
You can
that's
hear
it.
us, right?
Can you hear us?
Yep, we can see it. So we're gonna
Yes.
want to start at the rear end
Okay.
and work our way forward, so.
Right, so this is the boat tail that we're talking about. It's
Uh-huh.
bolted on there right now, but if you need to see it without the bolts, I can take it off.
No, you don't take it off.
This is kind of the fiberglass that we were talking about, and it's really hard to see, but there's that layer of aluminum tape on the inside. And then this is our motor casing,
Okay.
and then, so looking
So
at the
when we
front,
when we back up,
yeah,
yeah, go back there one more time for me, because it looks
Uh-huh.
like, yeah, I bet you the flame does torch it. What do you think, Lee? Or Eli?
Yeah, I'm trying to figure out the structural implications, and I'm not seeing the details on how that thrust ring holds.
Yeah,
Have you flown it with this configuration?
no, so this year for us personally is mostly like a learning year and gaining experience year. So we like ultimately decided not to do a flight test with this rocket. So it has not flown before.
So I'm concerned that the exposed parts on that boat tail are not flameproof or resistant in any way. And what happens if your rocket catches fire when it's under thrust?
Oh, I see what you
Having a
mean.
disposable part on, as your boat tail is one thing, but if your rocket catches fire, there's nothing to say that that anything like that wouldn't spread up.
Hmm.
What's holding the boat tail on? Is it
Right.
just those few screws in back? Do you have like 4 or 5? I start to see a pattern.
Yeah, there's 6. And these are all like rated bolts. They're a 1/4 inch 20
Yeah, so my question,
threaded.
if you were to take, and we don't need to do it, but if you were to take that boat tail off, what would we see underneath? How is that, what would we see underneath for motor retention? So there's that side I'm trying to figure out. And then to Elaine's point, as this thing goes in, and in about 3 seconds, that back end just catches fire. So now you have an end that's on fire that will then probably spread up to the rocket as it's descending. We probably have to think through this.
Right. So I guess I'll answer your first question. So basically this motor casing is like, there's a fiberglass like motor mount tube in here. And this casing is like leaning against that tube. That tube is connected to like all of our centering rings, and it's connected to the airframe. So it's leaning against that. And then the thrust plate thing that I was talking about before is all the way up here where these bolts are.
So that you're talking about
So it's
the structural force when it's giving under thrust, and I got that. That's not my main concern.
right.
It's when that
Okay.
ejection charge fires, it is going to put a huge amount of pressure inside that body tube. How does that motor casing not get kicked out the back? What is holding it inside the casing? So when your drogue fires, it doesn't kick the motor out the back and fail to deploy the drogue. And are you telling me that is it possible that motor is held into the body tube, kept from coming out the back with the boat tail?
No, so the boat tail isn't what's holding it. It's that thrust plate with the threaded rod. It's like threaded, like on it's the motor casing is threaded on that rod, and the
Okay.
rod is threaded on this plate. So like when there's an ejection charge, that rod in the plate is like holding the motor in place.
Oh, okay. I think I'm following now.
Yeah. Sorry, like
So-
it's there's not a way to like really open up the rocket and see it, so it's hard to
So
explain.
how do you mount? So right now, is that motor case bolted in?
It's not, well, I mean, the motor casing is in there right now. It's not like permanently in there, but it is in there.
How far do you have to reach in to screw the bolt onto the nut onto the bolt coming out of the top of the case? you-
The nut is like locked onto that threaded rod, so we just screw out the motor case from the back.
Okay,
You can take it out as well.
all right.
Yeah.
I got it visualized now. I've never seen that. Not sure if y'all have, been rolling. You've seen that?
Yeah, so the what, yeah, Aerotech does have a tap forward closure, quarter 20.
Yep.
In place of a
Yeah, it's
charge,
like
in place of a charge well, so. that-
Yeah.
Yeah. Well, some of us tried that method, but it gets to be somewhat on the tedious side of getting things to line up and screw in.
Yeah.
But it does work. It does. work.
Okay.
Okay, where, can we see your aft rail buttons? Or button, or where,
We were gonna put the rail buttons on last, so they're not currently on there.
okay, where are you gonna put them?
It's gonna be based off of the open rocket. So there's basically gonna be one, I think, like here near the fins. And then the second one is gonna be on our, I think it's the center of gravity location, which is like up here somewhere.
Okay, that works. Another suggestion is you don't necessarily need it at the center of gravity. One of the things to consider is that as soon as that first rail button leaves, then the rail buttons are basically not effective.
Okay,
So you can bring your rail button, your top rail button down further if you want to.
all
there's
right,
Nothing wrong with that, so.
okay. The only reason I was doing that is I like thought I remembered reading it on the rules document. So that's the only reason I would have gone with that. I could be wrong,
Okay, yeah, okay,
but
that's fine.
yeah,
And the rail buttons will be 15-15?
yeah, for sure.
Okay, all right,
They're already purchased. We just haven't put them on yet.
gotcha. No, that's fine. Okay, let's move up to your separation points for your recovery.
Okay, so the first separation point is right here. So it's basically, this is our electronics bay. It's through the electronics bay and right here. So we have some shear pins that we haven't taken out since the deployment test, but this is where it's going to be shearing. So then kind of connected to that, we took it apart so you can kind of see it better, but this is the end of the electronics bay, our shot cord, and then our main parachute, and the other end of the shot cord goes down in the rocket.
Okay, we just stay right there.
Mhm.
It sounds like the shot cord, the parachute, the bag and everything is brand new.
Yeah. We have done the deployment test with all of this, but it's brand new besides that.
Yeah, yeah, right. And your shot cord doesn't show any kind of burn marks or tearing or any of that sort of stuff.
No, not that I've seen at all. It's been like perfectly fine.
Okay, that is one of the things they will check in New Mexico is to make sure that that's in good shape for recovery. So,
Okay.
Yeah.
so you sounds like, okay, keep,
So
okay. Can you
how
point
tall
out
is your
your,
rocket?
What?
How long is your rocket?
It's 144 inches.
little over 12 feet,
So-
little under 12 feet.
Okay.
Yeah.
So I noticed that one of your recovery harnesses is only 30 feet long.
Yeah, it's like down in here. Like the harness starts at that thrust plate, and there's like 4 of the Kevlar lines that come up and like end here. And then there's a quick link like this that we can hook this shot cord to. So we can take it out of there if we want.
I was thinking in terms of it's probably not long enough. If if your payload is in the nose cone,
Uh-huh.
when your drogue is fired, the forward part of your rocket is going to be ejected with enough force to go quickly to the end of 30 feet and bounce, which may cause your main to be ejected at altitude as well. So one of the
Okay.
ways that you can mitigate that is to have a longer recovery harness. And they recommend somewhere between 3 and 5 times the length of the rocket for each recovery harness.
So,
So
like,
30 feet
not-
is kind of short.
Not the shot cords, but like the harness. Because the shot cords are this shot cord is 14 yards.
Okay, how about the other one?
It's 10 yards. So this is our main,
That's only
the
30,
drogue is
that's
10
only
yards.
30 feet. Yeah,
Yeah,
it's not long enough.
okay.
Which one's not?
And the harness,
The
the
30-foot
length of
one
the
is not
harness
long
is
enough for
there.
that. It's not even a minimum of 3 times the length of the rocket.
Okay,
40 or 45 would be better.
all right. I mean, I can buy another shot cord and add it on there
Yeah,
to make it longer.
yeah,
Okay, I can do that.
yeah. It would make it for a safer flight and less likelihood of bad things happening at apogee.
Okay, I could do that.
Okay. All right. And yeah, Elaine has a good point. You know, a longer shot cord doesn't hurt you, a shorter shot cord could, so.
Mhm.
Yeah.
Advice is try to be long as opposed to short.
All right,
Okay, can we see can we see where your where your portholes are for your altimeters and what size are they?
probably me.
So right now we only have one. We're gonna have 4 portholes, and they are, I believe, quarter 20 sized.
Okay, and that is based on reviewing the documentation for the altimeters to make sure you got the right sizes?
Wait, can you repeat that?
Yes, I assume that you looked at the manufacturer's specifications for port sizes for the altimeters.
For port site, I'm not aware of that. Our
Uh,
flight record told us that that should be a big enough size.
Okay. What you need to do, and I'm not going to argue one way or the other on the port size. What you need to do is review for each of the altimeters that you're using, the manufacturer's recommendation on port sizing.
Okay.
And I would recommend either 3 or 4 ports, and I would recommend they be evenly spaced around.
Yep.
Okay.
Yep, because 2 of them will be used where we'll stick our like screw into do our screw switches, and then the other 2 will be on opposite sides of each other.
Okay, just make sure that the switches don't block the port.
Nope, no, they won't.
Okay, all right.
And then
Oh,
4.
yay. Moving. Oh, let me see your sled and tell us how your batteries are mounted.
So our batteries, okay. So the nose cone will go that way. And so you can kind of see where we have it designated on our board. So right here we have the telemetrum, And right here, we'll have a Raven. And then we're gonna have two 9-volt batteries right here, and then a LiPo battery right here. And they are printed like casings that we'll be able to screw them down so they won't move around.
Okay, one recommendation would be to put your batteries on the opposite side of your electronics. That way, if they do come loose, they don't climb around and potentially damage your electronics.
Okay.
Okay,
Yeah, they should be able to, because they're all based around those rods. So yeah, I think that would be good.
okay. And the other thing, how are you going to secure your batteries?
So they're housed in a 3D printed casing, and those are screwed down to the board. All things are screwed down to the board using 440 bolts.
Okay, can I see the casing?
Yeah, I can get that out real quick.
Okay.
So here's an empty one. It's kind of like looks like that. And then here's one with a battery in it. The 9-volt.
Very nice. Okay,
Thank
very
you.
good. If that's coming out, you got real problems.
Yeah.
Is your tracker going on the sled?
Yes, because it's also acting as our secondary altimeter.
Okay, what kind of switches?
They are screw switches. They are, I believe, by MissileWorks.
Okay, all right.
Yes. There you go.
Be sure you have an extra set of screws. They do fall out of that particular model
Yes.
in your toolkit. Okay. Glee or Elaine, any comments? And that looks pretty good to me.
I'm ready to talk about the payload and how that is secured.
Yeah. Yeah. Oh, I'm headed that way.
Got it, yeah.
Not quite there yet. Okay, and as Lee said, let's move on to the nose cone and the payload and how that works.
Great. So anyway, it's on the ground. There's our drone chute. So a couple things we don't have for the payload. So one thing we got as a recommendation that is not in here that we're going to get made to help hold and support the payload is there's going to be like a thin centering ring around the top here. It's gonna be like laser cut that the payload can actually like sit on. It's gonna be epoxied to like the actual airframe. So like it's gonna be sitting on that, and like how the payload is attached right now in the nose cone. We have like these are a 1/4 20, 6 1/4 20 bolts that are threaded through it. And then it's a casing. So like this part holding the shock cord is going to be like bolted onto it.
Okay, is the payload going inside the nose cone?
Yeah, this is like a container. I can take off these bolts if you want, but it's like hollow inside of this.
Okay, so it's not going to come out.
Yeah, like when it's the payload, yes, it will be coming out. Like we can take it out if we wanted to.
No, okay, just make sure we all understand correctly.
Mhm.
The payload is contained within the nose cone.
Yeah, like throughout flight, it's just going to stay in the nose cone.
Okay,
What's the form factor on your payload? Is it just kind of,
Form factor?
so it's not a 3U. I mean, if it was 30 centimeters long, is it the 30 centimeters
Oh.
by 10 by 10? Does that actually fit in that nose cone?
Are you guys doing that part of the competition?
No, like the CubeSat?
Yes.
Yeah,
Yeah.
No,
Okay.
like we were gonna try to do like a researched payload with like seeds to see how the flight would affect like the growth of plant seeds. But that's all gonna be inside of this like round container. But it's not like the CubeSat form.
okay, so all that really means is you won't get any points for the fact that you're not using the CubeSat format,
Right.
which is their choice. They can do that if they want to.
Yeah. It's more of like the payload is like kind of been the last on our list of things to do. And it's just a lot easier for us to like have it in this like cylinder form than in the CubeSat. So that's kind of just the reason why it's a cylinder and not a cube.
That's
Okay.
right. It still has to weigh the correct 8
Right.
point something pounds.
Yeah.
Okay.
Yeah, the 8.8 pounds. Yeah.
Yeah, 2 kilos or 8.8 pounds. Yep.
Mhm.
Okay. Okay. Lee, Elaine, any other things before we do some general talking?
That's it for me.
I don't have anything else.
Okay.
We can move
Um,
back.
What is the experience of the team? Level ones, level twos?
So I'm the only one who has a certification, and I'm a level 1. I'm getting my level 2 this summer. Nobody else on the team has a certification. So kind of like what I said before, this year is definitely a learning year for us about gaining experience in the future. Like we haven't, as a team, we haven't launched a rocket since like 2019. So definitely like the main purpose of this rocket is to build experience and really have a learning opportunity for the members.
Okay. If I remember your report correctly, everybody at least has joined Tripoli, correct?
Yeah, everybody who is going to the competition does have their AAA membership.
Okay, cool. All right. And this will be your first competition, correct?
We the team competed in 2018 and 2019. But like during COVID, everybody who was on the team had graduated. So like anybody who had attended the competition in those years graduated. So nobody on this team has actually like competed in the competition. 3 of us went last year to volunteer to like learn about how the competition works, but none of us have actually competed.
Okay, that's excellent. I'm glad you had the experience last year. Because needless to say, it's a unique experience. So,
Yeah.
you know, for new teams, I usually go through a couple minute spiel on the fact that it's a desert and, you know, it's hot and dry and so on and so forth. But I think given you've got that experience, we could skip that on that end of it.
Right.
Are you comfortable with the contest schedule? Monday's registration, all team members need to be there. You need your cards, virtual cards, whatever.
Yeah. So we'll be getting there on Sunday. Ultimately we want to launch obviously as early as possible.
Right.
So just make sure we don't have any issues or we're not late or anything.
Okay. All right. So Monday's registration along with safety check. Tuesday is podiums and showing your rocket and further on safety checks. Make sure you get through safety check on Tuesday so you don't have to worry about it on Wednesday. Wednesday morning is set up. Wednesday afternoon we start flying. Thursday is flyable, and then Friday morning is flyable, and then after that we go to the award ceremony on Saturday, so. And you're familiar with the fact that the launch site is about an hour drive from Las Cruces?
Yeah,
So,
yeah, we went every day when we were there last year.
Cool.
So, yeah.
cool. Okay. I'll open questions up to the team. If they have any questions of Lee or Elaine or myself, fire away.
I don't know. I don't know if I had any questions.
Okay.
You definitely went, any questions I would have had, I think you went over. So,
I had a question.
Mhm.
When we spoke with our flyer of record last, he was talking to us about possibly using like well nuts, where we have locations that are bolted on. Do you think that that's like a necessity for us or something you would recommend?
The airframe tubing is fiberglass, correct?
Yeah, it's
Yeah.
G10.
Well, nuts definitely work. It's a common way of attaching rail buttons. The major advantage of it is it's easy to take them off. Since that's fiberglass airframes, you probably could just drill the hole, and you may want to try to tap it and just screw the bolt for the rail guide on with a little bit of epoxy to secure it in place. Either way works.
Okay.
It's your choice.
Any more questions? I don't think I had any more.
No.
Okay. If you can stop the recording now if you want to.